Today we are going to go over 6-2. Whoops, hopefully that didn't mess with my recording. Just checking, sorry. Can you input? Yes, you can still hear me. Good. 6-2, multiplying rational expressions. So we have fractions, and we're going to multiply two fractions. And whenever we multiply two fractions, we always want to make sure and see if we can cross-cancel first. So when I say cross-cancel, this is what I mean. When you have 6/5 times 15/24, cross-cancel means is there a common, we're reducing. So can we reduce this fraction? Is there a numerator and a denominator that has a common factor? Yes, they both have a common factor of 5. 5 goes into 5 once. 5 goes into 15 3 times. And then 6 goes into 6 and 24 have a common factor. 6 goes into 6 once. 6 goes into 24 4 times. And then we multiply across. So our answer would end up being 3/4. And remember, all we're doing is reducing fractions. If we saw 6/5 times 15/24, we would understand that that would be 6 times 15 over 5 times 24. And what we can do here, we can break it down. So 6 is 2 times 3, 15 is 3 times 5. 5 is already broken into its prime factor. 24 is 2 times 2 times 2 times 3. If we start canceling, 2 over 2 is equal to 1. What do we got? We got 5 over 5 is equal to 1. 3 over 3 is equal to 1. And that leaves us with 3 over 4. That's how we get 3/4. So we're breaking it down into its factors, and then we're canceling. And what we need to remember is 6 over 6 is equal to 1. -8 over -8 is equal to 1. X over x is equal to 1. 3x over 3x is equal to 1. X plus 2 over x plus 2 is equal to 1. And x squared plus 3x minus 4 over x squared plus 3x minus 4, that's also equal to 1. So anything over itself is equal to 1. That's why the 3 over 3 was canceling, and it cancels to 1. All right, so let's go back to here. So we have its numbers. So we're looking for items that are being multiplied. 7's in the numerator, 7's in the denominator. It's multiplying to the m, and it's multiplying to the 10m. So I can cancel those 7's. Those 7's will cancel out. I see I have a 2 and a 10, and that 10 is multiplying the m, so I can absolutely cancel it. And what goes into 2 and 10? 2. 2 goes into 2 once, 2 goes into 10 5 times, and now I'm done. What am I left with in the numerator? I'm left with a 1. What am I left with in the denominator? I have an m here, an m here, and a 5. So that gives me 5m squared. That would be the fraction. You would not multiply these two and then reduce it. You're always going to cross-cancel first. Let's do number 2. Again, we want to find a numerator and a denominator that has a common factor. So I see 3. 3 doesn't have a common factor in any of the denominators. I see a 6. And 6 and 10 have a common factor of 2. So I'm going to reduce 2 goes into 6 3 times, 2 goes into 10 5 times. These cannot cancel because they're both in the denominator. So we can only cancel numerators with denominators because that's where we get the value of 1. So no variables left, so I'm going to multiply those out. 3 times 3 is 9. 5 times 5x is, or 5x squared is 25x squared. So we're left with 9 over 25x squared. Number 3, we're going to look for a common factor. I see an 8 in the numerator, a 2 in the denominator. I know they have a common factor of 2. 2 goes into 2 once. 2 goes into 8 4 times. I look at these numerators, 4x squared. Nothing has a common factor with the denominator. So 4 times 4x is 4 times 4x squared is 16x squared. 5 times 1 is 5. Now, we can jump to much more complex. All right, so we're still looking for common factors. Well, I see a v minus 7 in the numerator. I see a v minus 7 in the denominator. I could have used this one. It doesn't matter. They both have a v minus 7. So I'll just use this because they're on right above each other. So those cancel because v minus 7 over v minus 7 equals 1. I see I have a 3 in the numerator and a 3 in the denominator. I'm going to cancel that. I'm going to cancel that with that. I see that I have a v squared in the denominator and I'm matching v squared in the numerator. So those will cancel. That cancels, that cancels. Now I'm left with a 3, nothing to cancel with the denominator and in the numerator, and I have a v minus 7 and there's nothing to cancel in the numerator. So my answer is going to be 3 over v minus 7. Also, really nice. So you see the benefits of when it's factored. When everything's factored, you're just pairing it up. So a minus 9, a minus 9, a minus 1, a minus 1, numerator and denominator. And that leaves me with a minus 2 over a plus 3. That's a nice, easy one. We love it when they're factored out for us. All right, same thing. I'm finding this denominator can cancel with this denominator. This b plus 2 can cancel with that b plus 2. And then I'm left with b minus 9 over 5. Super easy. Now we've got to do a little work. So I'm going to take each piece and I'm going to see I'm going to go through my list. I'm going to go through, number 1, is it GCF? Is there a GCF? Is it the difference of squares? Is it a binomial square? Do I have to do A times C? Or is it factor by grouping? So I'm going to start with the top left and I'm going to do each of the 4 quadrants. So I'm going to do the numerator of the first term, 7x plus 28. I can factor out a 7. That gives me x plus 4. So that turned into that. I'm going to look at the denominator here. I see that's a times c. It is not a binomial square, even though, because the square root of the first and the last times 2 does not equal my middle. So I do know what it's going to turn into. It is going to be x plus 4, x plus 1. How many people were able to do that? Were you able to look at the green one and do it in your head? Factors of 4, when added, equal 5. Signs are the same, both are positive. And that's really what I do quickly. So that was the bottom left factored. Let's factor the top right. Looking at it, are you going through factors of 8 when subtracted equal 7, negative 7. So factors of 8 when combined, the signs are different. So negative 8 and positive 1. Negative 8, positive 1. When you multiply those two, you get negative 8. When you add these two, When you add these two, you get -7. And that's what I'm doing. That's all I'm doing. And remember, this only works when a is 1, when your coefficient of x squared is 1. So that technique, that shortcut, is not going to work when a is greater than 1. And the last one that we'd like to do is the bottom left. We're going to factor that. That's got a greatest common factor, 7x minus 8. All right, now let's look for common factors, or common terms in the numerator and denominator. I got an x plus 4, x plus 4. I have a 7 and a 7. I have an x plus 1 and an x plus 1. Hello? Oh, I have an x minus 8 and an x minus 8. They all cancel out. So what's my answer? Is my answer 0? Is my answer 1? Is my answer no answer, no solution? The answer is 1, because everything canceled. 7 over 7 is 1. X plus 4 over x plus 4 is 1. X plus 1 over x plus 1 is 1. X minus 8 over x minus 8 is equal to 1. So 1 times 1 times 1 gives us a value of 1. Love number 7. All right, let's look at the top left. 3n plus 12. We can factor out a 3. We get n plus 4. We can't factor our lower left. Top right, we can factor in a 9, n minus 8. Bottom right, we can factor out a 9, n plus 4. And we can do it this fast. You should be able to. 9s cancel. And you're left with 3. Notice the 3 is in the numerator, so I write it as 3. That's our goal, is to get this done as efficiently and as quickly, but accurate. So let's look at the top left. Factors of 28 when added equal -11. Signs are the same. Both are negative. So I'm going to get minus, what's that, 7 and 4? And, okay, so you do factors of 28. 1 and 28, 2 and 14. 3, no, 4 and 7. And then you look at them and go, oh, that's 11. It's not a bad thing to write your work out. I'm just showing you that as you get more and more familiar with it, you'll sort of see the tricks of the trade. 40, 10, and 4, right? So plus 10, because I ended up with a positive 6. So when I combine those, I need to have my bigger is going to be positive. Signs are the same, both are negative. 28. Oh. Huh. So notice this. This is an interesting thing. Notice those are the same trinomials. You can just cancel those. You know you're going to get the same factor pairs, binomials. They would have canceled here anyway. So that can cancel. And then you can look at that n minus 4, n minus 4, and you get n plus 10 as your answer. So that's a tricky one. Definitely an interesting one. And it's good that we went through that process, and then I noticed after the fact. So before I start, I'm going to look at my 4 quadrants. Are any numerators the same, identical? These are kind of close. But nope, can't cancel those. So, all right, we just go through the process. I'm looking at the top left, 14. Does 14 go into 56? I don't know. I'm going to use my calculator to check, and it does. So I know that I can factor out a 14. How many seconds did that take? That took like 4 seconds. 8 definitely goes into it. 20x to the third, 70x to the second. So 10x to the second is my GCF. That gives me 2x plus 7. 14. Does 14 go into 49? I have no idea. 49 divided by 14? No, it does not. But 7 does. So I get 2x plus 7. Let's look for matching numerators with denominators. Numerators with denominators. 7 and 14. That becomes a 2. I can do 2 and 8. That becomes 4. I can do 4 and 10. 2 goes into those. So 2 goes into 4 2 times. 2 goes into 10 5 times. I've got this x squared here. And notice that I circle, and that gives me the opportunity to just keep track of what's left over. So I don't have anything left over in the top left. Top right, I have a 5x squared. Bottom left, I have a 2. Bottom right, I have nothing. So I'm left with 5x squared over 2. All right, 3 can't be factored any further. 6 can be factored out of that. These are not the same. However, let's look at this before I do anything. So I'm looking at the top right. I have a 2n squared, a negative 20n, and a positive 48. Remember, my number one is there a common factor? And there was. So we get n squared minus 10n plus 24. Okay. And let's factor that n squared minus 6n while we're here. We're still going to have to factor n squared minus 10n plus 24, but let's, I just want to finish this out. So that is factors of 16 when subtracted equals 6, 8 and 2. N minus 8, n plus 2. Okay, so let's rewrite this. 6 times n minus 4 and 2, and let's factor n squared minus 10. So factors of 24 when added equal 10, and signs are the same, both are negative. That's 6 and 4. 6 times 4 is 24. You got n minus 8, n plus 2. Whoa. Doesn't look like very much cancels here. All right, we'll deal with it. N minus 4 cancels. Did I do it right? So now 16, 8, that's right. 8, 16, 24, 6 and 4, yeah. Bummer here, all right. But 3 and 6 can cancel, that becomes 2. 3 goes into 3 once, 3 goes into 6 twice. And then the 2 here and the 2 there cancel. All right, so we are left with n minus 6 over n minus 8 n plus 2. Not the cleanest, not the best, but you had some stuff that was 11. Let's see if that was correct. 11. Yeah, good. All right, that's good. And let's do number 12. All right, so we see that they each have a common factor here. So we're going to factor out a 2 first. We get m squared minus 9m plus 18. 28m, I think a 4 goes into that. Yeah, 4. And that is 7m minus 2. 35, 60, and 25 goes into those. So let's start with 5. And we get 7m squared plus 12m minus 4. I think that's correct. No other factor left in there, so I know I took out the GCF. 10m squared, so I'm going to factor out a 10. I get m squared minus m minus 6. Whoa, we got lots of factoring still to do. All right, I'm back up to the top left. We're going to do a times c here, and you have m factors of 18 when added equal 9. 6 and 3. Minus 6 minus 3. Bottom left can't be factored anymore. Come on. All right, top right. So notice A is 7. So now I got to do a little work here. I got to actually do that work. 7m squared plus 12m minus 4. So I got to do A times C. 7 times negative 4, negative 28, factors of 28, 2 and 14, 4 and 7. Signs are different. Bigger is positive. There's my 12. So that becomes 7m squared minus 2m plus 14 7m minus 4. I can only factor out an m. 7m minus 2. I can factor out a 2. 7m minus 2. So I get 7m minus 2, m plus 2. Okay, and that is going to go back up for that one. So what was that? That was 7m minus 2 and m plus 2. M plus 2. So you notice that I had to do a little work for that one. Bottom right, I can do mentally. I'm okay with that one. That's a 10. Factors of 6 when subtracted equal 1. Well, that's going to be negative 3 and positive 2. All right, let's cancel. We've got a 7m minus 2, 7m minus 2. We've got an m plus 2, m plus 2, m minus 3, m minus 3. I've got a 5 and a 10. The 10 becomes 2. I got a 2 and a 4. The 4 becomes 2. And I'm left with this in the numerator, nothing else, this in the denominator, and this in the denominator. So my answer is going to be m minus 6 over 4. Yep, and I'm just taking a second to make sure. Excellent. And then you can check those answers against the answer key. Nice job. I love this. This is fun. Hope you enjoyed it. Come and see me if you have a question.